I said earlier that you cannot have a radical in the denominator. It's fine in the numerator, no denominators. Here we have that, 2 over root 5. So the nice thing is, you guys are very familiar with changing fractions. If you had 1/2 plus 1/3, you would change both of those fractions to give them a common denominator. So you would multiply by 3 over here, but if you do that to the bottom, you have to do it up top as well. Same thing on this, you have to multiply both the numerator and denominator by 2. So as long as you are multiplying the same thing in the numerator and denominator, that's fine. So I'm going to show you a couple ways that you can do these problems. Choose whichever way you like better. 2 over root 5. Our big thing is we have to turn it into something that we can square root. So what you can always do is multiply it by itself. We can multiply by the square root of 5 because, remember our smiley face trick. Square root of smiley face times the square root of smiley face is just regular smiley face. Right? So the square root of 5 times the square root of 5 will just eventually work out to 5. Because 5 times 5 is 25, and the square root of 25 is 5. Great. So if we multiply the denominator by root 5, we have to also multiply the numerator by root 5. Now if you have a regular number like 2 times a radical, you just kind of mush them together. 2 times the square root of 5 just becomes 2 root 5. Cool. Check the stuff outside the radicals and see if you can simplify those, like the 2 over 5. If you had the fraction 2/5, you would just leave it. So this will be our final answer. That's one way to do it. Another way, after you do a few of these, you'll kind of notice a pattern. What you can do is just bring the radical up to the numerator, make it 2 root 5, and then the denominator, the radical just vanishes. So if we had something like 5 over root 6, you bring the root 6 up, make it 5 root 6, and then the denominator, the radical just goes away, 6. Great. Let me show you this. If you had like 10 over the square root of 2, you bring up the radical, make it 10 root 2, denominator radical just goes away. But check to make sure you can't simplify anymore. We have regular 10 over regular 2. 10 divided by 2 is 5. So our final answer here would be 5 root 2. These are all just made up problems. So we just riffed those. Let's try some more that they have here. So root 7 over root 8n. So again, I'll show you what I know. I'll show you the ways I can do this, and then choose which way you like better. So the best backup way is to always just multiply it by itself. Times root 8n times root 8n. Now denominator, the square root of 8n times the square root of 8n would be just regular 8n. The numerator, they're both under radicals, so we can multiply them together. 7 times 8 is 56, and we have n. But 56 still has a perfect square. 56 is 4 times 14. 14n. The square root of 4 is 2. We have 2 root 14n over 8n. And then we're able to simplify the stuff outside the radicals. Think of the fraction 2 over 8. That would reduce to 1/4. So this becomes a 1, this becomes a 4, so our final answer would be 1 root 14n over 4n. That's probably the most consistent way to do the problem. But let me show you another way. Because remember, our whole goal is to be able to square root that denominator, turn it into a perfect square. So 8, we turned it essentially into 64, right? 8 times 8. We can also just turn it into 16. So I'm going to stop the video here, and I'll show you that on the next one.